Hello and welcome. I'm Dr. Pauline Fu. In this video, I will continue hypothesis test for a population mean. Last lecture, I left off at an example. So I will quickly begin with this example and continue moving on. This example is about resting metabolic rate, RMR, of healthy males in complete silence is 5,710. Researchers measured RMR of 45 healthy males who were listening to the calm classical music and found the mean RMR to be 5,708.07 with a standard deviation of 992.05. At 0.05 level of significance, is there evidence to conclude that the mean is different from 5,710? So last lecture, I did the first 3 steps. Step 1, maybe I will erase the annotation. Step 1, state the null hypothesis and alternative hypothesis. Step 2, specify alpha. Step 3, calculate test statistic based on sample mean x bar minus population mean over sample standard deviation over square root of sample size. Okay, and how do we get this sample mean? It is given here. See, this one is x bar, this number, okay, and this number is population mean mu, hypothesis top number, okay, and we come up with the test statistic negative 0.013. Because H1 has not equal sign, we determined this is a two-tailed test. Okay. And this is the picture of two-tailed test. Okay. So we need to find the critical value. What is the critical value? Okay. In order to find the critical value for T, you need two items. One is the area, okay, area to the left, okay, and the other is degree of freedom. Okay. And you can use this one using Excel. Okay, I give you the note. There are different ways to do it. One, you use t.inv.2t. 2t means two-tail, and you substitute the probability with 0.05 degree of freedom 44. You get 2.02, okay, to keep 2 decimal places. The other way is you use t.inv, but you have to use half alpha because this is two-tailed test, okay? And you get negative 2.015, which is this point here, negative, okay? Because the area is based on to the left of the T value. Okay, so this second value, you get the negative. And the last one, when you type in this formula, you get positive. So it is this number here. Okay, this is where I left off from last lecture, part 1. So I call this lecture part 2 of hypothesis test for population mean. Okay. Once you get it, so I'm going to use Excel to verify so that you know how to use Excel to do the critical value. So I'm going to erase all these numbers So I want to find the critical value given alpha 0.05, given degree of freedom 44, given it is a two-tailed test. Okay, so you have three ways to do it. 1t dot inv dot 2t. Okay. Probability 0.05, degree of freedom 44, and you get 2.02. This is one way. And the other way, t dot inv. Okay, use half alpha 0.025, degree of freedom 44. You get negative, which is this value here. Okay, and the last one, you use because when you calculate critical value, it is based on the area to the left. And if you have this point, it is based on the area to the left. Okay, so if you want to find this point, you have to substitute this area. Okay, and what is this area? Because this is two-tailed, you see this is half alpha. Alpha 0.05, half alpha 0.025. So this area, little right tail, 0.025. And remember, the whole area on the bell-shaped curve is 1, so this area must be 0.975. Okay, so when you use Excel, you should use equal t dot inv 0.975, degree of freedom 44, and you get 2.02. Okay, so this is what I left off from last lecture. And once you have this step 4, you compare critical value with test statistic. Okay, so we know the critical value one is 2.02. The other is negative 2.02. Critical value decide rejection region. So this is rejection region. This is rejection region. Okay, rejection region, rejection region. Now, locate your test statistic in this diagram. So test statistic negative 0.013. Okay, negative 0.013, maybe here, because this one is 0. Okay, so this is your test statistic. Obviously, the test statistic is not in the rejection region, so you do not reject H0. Okay, so this one you do not reject, means the population mean is 5,710. So this is the classical approach. Next, we present the p-value approach. When you do the p-value, you need to find the area. So what is the p-value? P-value is the area corresponding to test statistic. Remember, our test statistic is a negative 0.013. Negative 0.013. So what is the p-value? P-value is the area corresponding to test statistics. So this part is a p-value. Because it is two-tail test, you have to multiply by 2. 2 multiply this area. 2 multiply this area equal to p-value. Okay, and the question becomes, how do you get this area? How do you get this area? Okay. Again, you can use the t-distribution table, okay, to find this area. Or you can use Excel. Okay, where is my Excel? So Excel, I'll try to. So T dot, maybe I'll try to increase the font size for this cell. So equal T dot DIST. Okay. If you tell Excel it is 2 tell, you do not 2 times 2 because the computer already know it is 2 tell. Okay. And X is a negative 0.013, degree of freedom 44. Oops. This number T dot int. Maybe I need to change to positive to see what happens. Yes, you need to change that to 1 so that the value you get, you have to use 1 minus this number. And this is your p-value. Okay. So what I did, I will show you the formula. I use this one, Control C. Okay, and this one equal to 0.9. 9897. Okay, because it is 2-tailed test, I try to use another symmetric value. If you have negative 0.013, you must have positive 0.013. And both T distribution table and Excel is based on area to the left for T, area to the left. So if you have this one, so the area to the left is this one here. Okay, so you get this one. And then you have to do a little bit conversion. This area is 1 minus 0.0897. Okay, 0.0103. Okay, so this is the area. And then because it's 2-tailed, p-value is 2 times of this area. Okay, and you can get p-value. Okay, so p-value, let me see, this is test 0.0013 distribution. Yes, so p-value is 0.0206, and this p-value looks like this is not the p-value. Let me see what's going on here. Okay, we get a test statistic. We need to find the p-value. Okay, p-value. I don't have table in front of me. P-values, this one, T distribution, 0.013. Test statistic, but if I put in this negative, the test statistic is negative, we get negative 0.013, but it gives me error information. So if I go to the table, I try to find the table, okay? Documents, my first block, tables and formulas, right? maybe I will insert this into the OneNote so that I can reference. I will create a page. It is called Tables and Formulas. So what I'm trying to do, try to figure out the p-value tables, formulas. So I'm going to insert that PDF file. It is here. And the resources, formulas, and tables. I posted the tables and formulas on Sakai under the resources folder. You can access the same PDF document, okay? All right, so this is the, it looks like too small. Try to find the T table. This is normal distribution. This is an area. Okay, this one is here. This is the T table, okay? Try to increase the font size. Okay. So this is T distribution, okay? Because it didn't provide a negative number. Our test statistic is negative 0.013. We have to consider a positive number, okay? Later on, we, so anyway, we find degree of freedom 44. If you don't have 44, choose the one close to 44, maybe 40 or 50. It won't change the result, okay? Let's say 40, okay? And then area in the right tail. Now this is found critical value. I already have a value 0.013, so I try to locate that value 0.013. Do I have another table, T table? This is standard distribution. This is chi-square. This is T. This is the table. So degree of freedom, area in the right 0.025, then I get degree of freedom. This is the critical value. Well, now I need to find the p-value. P-value is here. I can only find the range, not exactly p-value. Okay, so I'm going to say my test statistic 0.013. So when degree of freedom is 40, 0.013 is smaller than this number, right? 0.681. So then I go up. Okay, and I can say p-value would greater than 0.25, not p-value. So what I try to do, so there is a point, 0.013. Okay, this is a test statistic is negative, but the table does not have negative number. So we have to use a positive number to do p-value. So first locate positive 0.013 0.13, it is here. And this number, when degree of freedom equal to 40, is smaller than this number here, 0.681. Okay, that means when you look at up here, those are the area corresponding to T value. The area, say, goes down from this direction. Area goes down, and from this direction goes up. And your number is smaller than this number. So if you go up, okay, this area must be greater than 0.25. This area greater than 0.25 because it is two-tailed. So this area plus this area must be greater than 0.5. Based on the table, we cannot get exact p-value. We can only find the range of p-value. We can only say in this example, p-value greater than 0.5. Okay, so go back to my presentation. So I will maybe erase those. So we can say p-value is greater than 0.5 based on the table, greater than 0.5, and alpha is 0.05. Of course, p-value is greater than alpha. When p-value is greater than alpha, do not reject H0. The same conclusion as we get, do not reject H0. The same conclusion as we get using classical approach. Okay. So we spend a little bit of time figure out the p-value. Okay, how do you look up into the table? Okay, you just can get the range. So step 5, make conclusion. There is insufficient evidence at the 0.05 level of significance to conclude that the mean is different from this one. Okay. It is double negative, the conclusion. So insufficient to prove different means this one is correct and we reject actually H1. We don't accept H1. H0 is correct. But your conclusion usually use double negative. There is no efficient. There is insufficient evidence to say this is not. Okay. Like this one here, differ from this one. Insufficient to say it is differ from this one. Means it is this one here. It is this number. So this is one example. Okay. And next, look at a small sample example. Okay. According to the United States Mint quotas, weight 5.67 grams, a researcher is interested in determining whether the state quotas have weight that is different from 5.67 grams. He randomly selects 18 state quotas, weight them, and obtained the following data about this 18 sample size. At 0.05 level of significance, is there evidence to conclude that state quotas have a weight different from 5.67? When you have large sample, means sample size greater than 30, we usually assume sample come from population having normal distribution. However, this example, sample size is 18, smaller than 30. So this is a small sample problem. We have to make sure to check the condition. Okay. And first of all, the question asks you different. So we know when you have different, it is usually a two-tailed test. Okay, because the sample size is small, we need to verify that it is coming from normally distributed population before we can do step 1 to 5. So how do you know the sample coming from population having normal distribution? You use normality graph. If the normality graph looks like on the straight line, we assume normality is matched. And how do you produce this normality graph? You go to Excel, okay? You punch in the data. For example, you have 18 data here, okay? You punch in the data, and then you go to data analysis, and then you can do the descriptive statistics. Normal probability plot. Usually it is oops. It is not here. Let me see. Histogram. So if I'm interested in this data, I want to produce normal probability plot, correlation, exponential smooth moving average regression, I can do histogram to see if I can get normal probability plot now. If I do the regression, I should have see, normal probability plot. You can do regression, you get normal probability plot, okay? And from that plot, you can see if the data come from the population have normal distribution. Okay, so this is the normal probability plot, looks like on a straight line. So normality appears reasonable. Okay. And then you can produce a box plot. And this is the box plot with a 5-number summary, okay? Minimum, Q1, Q2, Q3, maximum. Looks like there is no something outside this. So no outliers. Start crunch have a function to produce box plot, okay? So we assume the conditions are met. Now we proceed with 5 steps. Step 1, state the null hypothesis, mu 0 equal to 5.67. Alternative hypothesis, mu not equal to 5.67. Step 2, level of significance. Step 3, calculate test statistic. Test statistic equal to X bar. How do you know X bar is this one? You go to original data. This is original raw data. Punch in those data in Excel or your calculator to find X bar. Not only X bar, you can also find standard deviation. Okay, chapter 3, knowledge. Okay. All right, so you have this is X bar, okay, and this is standard deviation. And this is population mean here, 5.67. This is sample size, and you get 2.75. 2.75. Once you get 2.75, we can use classical approach to find critical value. Because we have for sample size 18, so degree of freedom is 17 degree of freedom. Okay, and the critical value we get is 2.11. The other is negative 2.11. So now, since I have table, I will use table. How do I find this critical value based on table? So first, identify degree of freedom 17. And now, use, because it is two-tailed test, we need to use half alpha. Okay, so half alpha is 0.025. So go to the table. this table, I'm going to erase the previous one. Locate degree of freedom. Let me double check something so that we don't miss. Okay, sample size is 18. Degree of freedom is 18. Locate 18. And then locate 0.025. Okay. The intersection part between 18 go right. And 0.05 go down. And this number is the intersection between 18 and 0.025. So this number is 2.101, and that is your critical value. Okay, so this is how you found critical value. Okay. So go back. We get critical value 2.11, and we know it is two-tailed. The other critical value negative 2.11. Okay, so we strongly suggest you draw a diagram, label those two critical values. One is 2.11, and the other is negative 2.11. And also label the rejection region. Critical value decide rejection region. Okay. And then label test statistic 2.75. 2.75 must be here. See, 2.75 is in the rejection region, so you reject H0. You reject H0 and conclude the population mean is not 5.7567. Okay, so that is a classical approach. Next is the p-value approach. Again, you need to find the p-value. Remember, p-value is the area corresponding to test statistic. And we have our test statistic 2.75. 2.75 is test statistic. So this is the area corresponding to test statistic. Because it is two-tailed, we need to use this area multiplied by 2. Okay. All right, so let's go to the table to find the p-value. Remember, when you go to the table, you can just find the range of a p-value. Okay. So, and remember this one degree of freedom is 17. Table. So erase the 1, locate degree of freedom 17. 17, okay, locate degree of freedom. And then within this one, our test statistic is 2.75. 2.75 is between these two numbers. Do you agree? 2.75 is between 2.567 and 2.898. Once you locate these two numbers, go up. So we conclude p-value is between 0.01 and 0.005. That is the area to the right of test statistic. So between this number, and then you have to times 2. Okay, so any number between this number, that is the area to the right. So let me remember this number, 0.01, 0.005. So this area is between 0.001 and 0.005. Let me double check. 0.01, okay, I have extra 0. So 0.01. Okay, so p-value between this number and this number. Not p-value, it is this area. This area times 2, that is p-value. Okay, so we can say times 2. Maybe it is between this number and this number. Okay, so we can say p-value is smaller than 0.05. Okay, so we can say p-value smaller than alpha 0.05. When p-value smaller than 0.05, you reject. Okay, you reject. Okay. So we get the p-value. Another way to get p-value is to use Excel. I type in the formula here. Okay, how do you use Excel? T.dist, you get area. 2.75 is our test statistic. The Excel you get is the area to the left. So you have to change to area to the right. You have to do a little bit calculation. Okay, to get the area to the left is this one. Okay, and this one multiply 2. So exactly p-value you can find from Excel, exactly p-value. It is this number 0.0068 multiplied by 2. That is your p-value. Okay, and based on p-value method, you reject H0. Okay, all right. Pause. More. Stop. No, pause recording now. Where is the share button? Stop share. In summary, what I did in this lecture, it is continue with the previous lecture about hypothesis test for population mean. There are 2 methods. 1, classical approach. 2, p-value approach. In both methods, you need to make sure the sample size is large. If sample size is small, you need to check the requirements. One of the requirements is population is normally distributed. The other requirement is not outliers, and also make sure the samples are independent with each other. Okay, and that's all for hypothesis test for population mean. Thank you so much. I look forward to see you next time.